when we actually put these linear equations into practice, it can be a little bit challenging. But if you understand that every dependent variable, when you're given it, every independent variable will tell you what the dependent variable is, like an input or output. It'll make sense once we do it. So I'm actually going to do this using some bar models. It says that Mandy spends $8 during lunchtime. So Mandy, I know, spends $8. Now Jason spends $4 more than Mandy. So he spends what she spends, but an additional 4. So we would call Jason's amount an A plus 4. But then they say up here Jason spends B. Well, he spends B, but he also spends Mandy's plus 4. So I know Jason's B equals A plus 4. And what I realize here is that the independent variable is A, and the dependent variable is B. B fully depends on A. I need to know A before I can figure out B. Then they go on and they say, okay, in this case here, here's all the money that Amanda spends, or that Mandy spends. So here's all those A's. What will the B become if these are all the A's? Well, if Mandy only spent $1, then 1 plus 4 is 5. But if Amanda spent $2, then it's the amount that Jason spends is 6, because he always spends 4 more. If Mandy spends $3, then Jason spends 7, Mandy spends 4, he spends 8, Mandy spends 5, spends 9. It's always $4 more. But what ends up happening here is I've got these pairs of numbers that go together. I've got the independent variable and the dependent variable that I can use on a coordinate plane. So what I'm going to do is set up a coordinate plane where I can actually plot these. So first what I'll do is let me set up my x and y axes. I'm going to do it like this. And what I know is that my x, back when I used to do coordinate plane, x always went down here because x was independent. In our case now, we know that Mandy's amount, A, is actually the independent here. That leaves the y as the dependent. And in this case, Jason's the dependent. These would be referred to as the B. So I'll set up my number line here. I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So I'm going to see what independent goes with what dependent. So when the independent was 1, its dependent was 5. When the independent was 2, 6. When the independent was 3, its dependent was 7, 4, and 8, 5, and 9. And what I see that's happening here is I'm creating this line, or a linear equation. So I can put these things on a coordinate plane. Why don't you try this one and pause it, and then we'll go through it. It says Adrian has H card games. Ben has 2 fewer than Aiden. If Ben has P, write an equation relating P and H. Then they tell you how many Adrian has, how many does Ben have, and then you can actually plot them. So why don't you pause it here, and then we'll go over it. So Adrian has H card games. So I'd write Adrian down here. I would call Adrian A. Let's say Adrian is H card games. And then they say that Ben has 2 fewer. So Ben has the same H, but just without 2. So we would call this amount here H without 2. So Ben has Adrian's H just without 2, so I take 2 off of it. They go on to say that Ben actually has P card games. So I know that P is the same as H minus 2. So our equation here is that P equals H minus 2. Now I'm going to put this into play. So if I know Adrian's H, so what I know is that Adrian's H is the independent, and I know that Ben's depends on whatever Adrian has. I can't figure out Ben unless I know Adrian's. So if Adrian's got 2, then Ben must not have any, because 2 minus 2 is 0. If Adrian's got 4, then Ben's got 2. If Adrian's got 6, Ben has 4. 8 gives Ben 6, and 10 gives Ben 8, because Ben's always going to have 2 less than Adrian. What I'm then going to do is put some things on a coordinate plane here. So I'm going to create an x-axis and a y-axis. I know that normally this is the x because it's independent, but we've discovered here that Adrian's h is actually the independent. And I know that Ben's p is actually the dependent. Now, I'm going to number these 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. I'm going to go over these other ones. This is 0 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And I'm going to compare my independence to my dependence. When the independent is 2, so when the independent's over here at 2, the dependent's at 0. Okay, so I've got a point right here. When the independent was 4 over here, the dependent was 2. When it was 6, the dependent was, looks like 4. When it was independent was 8, the dependent looks like it was 6. And when it looks like the independent was 10, put this here at 8. And what I've discovered is that once again, I have this linear equation, this straight line that shows that all of these inputs and outputs, the independent independents, are all interrelated.